And let's go. And let's go.
Hey folks, today's going to be a nerdy one. As you can see, I'm wearing my Cobain glasses. I don't know if I'm going to keep them around, maybe, I don't know. Let me know what you think. I am also drinking a Pelican Brewing New World India Pale Ale, which is quite delicious. I do like this stuff from Pelican Brewing. It's all been pretty good. I've had two other kinds. Cream Ale is pretty awesome. That's the one I remember anyway, and the IPA. Anyway, today we're going to be talking about LinuxCNC and its GUIs, and then the virtual control panels underneath those GUIs. Some of them, anyway. So, let's just jump in. Okay, to start, we basically have user interfaces. Easy enough. There are essentially four main ones. There are some deprecated ones. If you look at the LinuxCNC docs, you'll see these. We're going to talk. Right, so I'll just start from the bottom. So essentially, there is G-Screen, which is a mostly a touch interface based user interface. We have actually also Touchy, which is another touch based one. We have Gmock APY, Gmockapy. I don't know how you necessarily pronounce that. Gmockapy sounds pretty good to me. And then we have Axis, which is essentially the default one. So, before we get too much further, each one of these, they essentially have their own virtual control panels, which we're not going to talk about right now. We're going to go over to the computer, and we're going to look at Axis first. Alright folks, back at the computer, and I just wanted to show you like what these different user interfaces look like, just in case you haven't had a chance to check out the docs. There definitely is good information about each one in the documentation, so I'm not going to dive too deep into it. This is more just like an overview of like what these things look like, and then I'll dive more into the virtual control panels because that's a little bit more confusing. So to start with the Axis GUI, you're probably familiar with this one. It essentially is like the default LinuxCNC GUI, and it looks like this. The underlying virtual control panels, which I'm going to talk about in a second, that Axis allows to control it are Glade VCP and Pi VCP, whereas the other ones, so for instance, Touchy GUI, the Touchy interface, has its own components. So I don't think Glade or Pi VCP can control this or work with it. But if you look at Gmockapy, Glade is the primary. Well, actually, Glade is the only sort of interface tool, virtual control panel that's allowed or able to program it. And then you have G-Screen, which is similar to Gmockapy in the way that Glade virtual control panel is used to program interface elements. So to wrap up, Axis is allows Glade and Pi VCP, which is short for Python virtual control panel. Touchy, none, has its own elements that you have to work with. Gmockapy essentially uses Glade. G-Screen also Glade, and that's what they look like. So I'm going to go back to the table, and we are going to talk about virtual control panels. Alright, to recap user interfaces, G-Screen, GMyKP, Axis, Touchy. We're mostly going to focus on Axis and PyVCP today, I think, but we'll dive into Glade VCP in the future more. So essentially, each one of these user interfaces has a virtual control panel, except for Touchy, which not quite sure. I guess no virtual control panel. So moving on. All right, so now we have virtual control panels. There are two: PyVCP, which we're mostly going to focus on today, and Glade PCP, not to be confused with Glade plugins, which smell bad. Okay, back to the computer to talk about PyVCP and Glade VCP. All right, so back in the computer, we're going to talk about Python virtual control panels, or PyVCPs. So they're mostly, like, the basic thing to know is that there are two main components. There's the XML file and then there's the HAL file. And the documentation is pretty good explaining those. Here's what they look like. It's all the examples. Let's just dive in and see for ourselves what they look like. So what I've done is like downloaded the GitHub LinuxCNC project, just cloned it. Inside of there, you go to configs, apps, PyVCP. You'll see there are 4 files. The main two, HAL and the HAL file and the XML file. That's what you need to mostly focus on. The .demo file is just an executable. It allows you to see what it looks like. So let's just do that. So if we go to Open with Terminal, you need to make sure you open it with Terminal. Just click on it. Oops, looks like it's already active. Here we go. Cool. Lots of knobs and sliders and stuff. Yeah, pretty basic. This is called your spin box, and then you can find out what all these widgets are called through the documentation. So let's dive into some of the details of the HAL file and the XML file. So we're going to start with the XML file. It's pretty basic. So you essentially, inside of here, you have all the properties of the different widgets, and you can find all about those properties in the documentation. But the main thing you need to know is you need to start the XML file with the XML string here. Just lets the computer know this XML file, or the processor know that it's a valid XML file. Then PyVCP, the PyVCP tag. And then there's a couple other ones. I'm not going to talk about too many of the properties, but HAL pin is pretty confusing, or was for me at first, to just wrap your head around. So let's talk about that one, and then maybe param pin. So HAL pin is essentially just naming the pin that allows you to connect to the HAL file. So right now they've created spinbox 0. So let's go into the HAL file and look and see what that looks like. So what we see in the HAL file is spinbox period dot 0, or period 0. So that might be confusing to you, but essentially what it's allowing it to do is like actually get the value from spinbox, and that's the sort of destination syntax, I guess, to get that value. So if you're confused by this line, just go check out episode 19, where I talk about like HAL commands and like how this stuff breaks down. But you essentially have your net, which is a command. So there's all these are essentially net commands. You have your signal. This is just actually I'll talk about that in a second. You have your signal, your signal source, and then this arrow just is used for human readability. It doesn't, the HAL processor doesn't actually read it, but it just shows you that the signal source is going to these destinations. So I actually like to think about it like this. So it's more of your signal source is going to your signal name. So this can be named whatever you want it to be. And you can reuse this within the HAL file to send that signal to signal source to other destinations, just via the signal that you named it. But essentially your signal source is going to your signal. Your signal is then going to these destinations. It's a little easier to think about it that way, I think. So before we get too deep into this, let's go and look up scale 0 to see where our signal source is coming from. Alright, so we're in scale 0 here, and let's open up our demo so we can see what this looks like. So the scale 0 is this guy right here, I believe. Let's just check. So scale. Yep, so the scales look like that. So scale is essentially there, and that value is getting sent to the spin box. So if we go and look at our HAL file, scale 0 is getting sent to the spin box that way. And this param pin, so if we go back to XML, you can see that the spin box 0 has a param pin, and that param pin is set here. So it's essentially set to true. So all that says is that it's allowing the scale widget to be have like an initial value set to it. So if we look up param pin in the documentation, you can see if it's set to true, a pin will be created that can be used to set the spin box to an initial value and to remotely alter its value without HID input. So without us having to actually drag the slider, if you set param pin, you can actually control it via another signal from the HAL file. And that's essentially what they're doing there with number 0, I believe. So, yeah, I mean, I know it kind of went fast there, but just know that HAL pin and param pin are pretty important. All this stuff is pretty well documented, so take a look. It is confusing though, like with HAL pin, like how the destinations are set. I'm not completely sure why that is. I mean, I don't know why the syntax is completely different, but whatever. But essentially spinbox 0 here is linking up to spinbox 0 here. So that value of this spinbox is the destination here. So hopefully that helps you. And yeah, like I said, it's just an overview. I'm not going to dive into too many more details, but it is pretty well documented in the documentation. But hopefully that helps you wrap your head around what PyVCP is and does. I guess another pretty important thing to note is if you've never worked with PyVCP, it essentially adds a, it's only used in Axis, by the way. You can't really use it with Gmod KP or Gscreen or Touchy, but it essentially adds this side panel to Axis. So these are where the widgets end up. They end up here. Even though our demo is launching in its own window, that's not necessarily the case once you actually add these HAL files to your project or your actual configuration file. So let me just go into that real quick. Actually, it brings up a good point. So if I go into, I'm going to go to my main LinuxCNC config, so Shoreline Mill. These things actually live inside of so custom panel.xml. So that's a HAL component of the HAL or PyVCP, and so we open that up. And you can see inside of there we see PyVCP at the top, so we know that's a PyVCP file. And then if we go to custom PostGUI, is these are all the HAL commands that PyVCP is looking for. So they have to be in PostGUI. Custom.hal won't work; it won't be able to process it. So essentially, after the GUI is loaded, then these HAL commands are run. So let's open up those, and you can see also more net commands. Same stuff, just different names. And these rapid to home essentially just links to rapid to home inside of this custom panel that I have set, like that. So hopefully it helps. All right, so let's talk about Glade PCP. I'm not going to dive into it too deep because this is just an overview of like what these things are right now. But you can essentially use them to update G-Screen, WYSIWYG, and Access. So it's pretty powerful. One of the cool things about Glade is that it has a WYSIWYG editor, unlike PyVCP, where you have to just edit the XML. Definitely want to learn more about it in the future. I think it's going to be handy to know. There's a good overview of like what the differences are between PyVCP and Glade VCP in the documentation, and I'll definitely add that to the notes in the description. But it's definitely it's more powerful. Just know that. And it has the WYSIWYG editor. And I guess to dive into a little more detail, so whereas PyVCP relies on TK enter, Glade VCP relies on GTK, or PyGTK actually. So TK enter wraps TK, or is a Python binding for TK. PyGTK is a binding for GTK. So you can see PyGTK, if you go to pygtk.org, you can read more about that. And then that'll sort of lead you to the GTK Plus project, which is essentially, GTK Plus is essentially just a bunch of GUI helpers. And PyGTK is a binding for GTK Plus. And then Glade allows you to interact with all those components via WYSIWYG interface. So hopefully that wasn't too confusing. To recap, so TK enter is a Python binding for TK, and TK enter is nothing but a bunch of widgets, user interface widgets. PyGTK is a binding for GTK Plus, which is also another combination of user interface widgets. And then Glade allows you to use those via WYSIWYG editor. So let's go see what that looks like. So I'm gonna, if you've installed LinuxCNC, I'm just gonna go to development and then Glade, and this is essentially the interface, the Glade interface. So now I'm gonna open up one of the example projects. So you can find these in the, if you just download the LinuxCNC project from GitHub and just clone it. If you go to config apps and then Glade DCP, you'll find some examples. So I'm going to open up one of those now. So I opened up the Caro Draw, which is under the animated demo, and you probably will see there's not much there right now. So you have to like go over here and click on Window. Window there, and then you'll see. So inside of there, I'm not going to dive too deep because I don't know a whole lot about Glade right now. Maybe in the future I'll be able to explain a little bit more. So yeah, I feel like this signals panel is like very important, but I don't know enough to tell you about it right now. But I just want to show you, this is just an overview. So this is what it looks like. This is how to sort of get started with it. Start diving in, and good luck. The documentation for Glade VCP looks pretty in depth and well done. There's plenty of information there. Hopefully in a future video I can dive in and show you some gotchas. I'm sure there are some there. But for now, hopefully that helps just to wrap your head around like these virtual panels. It definitely was a little confusing. I mean, trying to understand like how these things connect and to create a mental map of all this. So yeah, hope that helps. So just wanted to do a quick recap. Hopefully the video wasn't too confusing for you. You essentially have four main different types of GUIs that you can use with LinuxCNC. There's the Access GUI, which is sort of the default one that you're probably familiar with. There's Touchy, which is like a touchscreen based GUI. There's WYSIWYG, which is another sort of touchscreen, but you can also use keyboard and mouse with that. And then you have G-Screen, which is another sort of touch-based system. I think maybe a primarily focused touch-based system. And then you have underneath these are virtual control panels, which allow you to program different widgets for them. So for Access, you can use PyVCP and Glade VCP. Touchy, you can't use either of those. GMOKP, you can use Glade, and then Gscreen, you also use Glade VCP. So, yeah, hopefully that gives you an overview of like how these things sort of interact with each other, so you can start diving into the documentation and learning more about them.